If you look at human anatomy, we operate on a strictly centralized blueprint. One brain processes the information, and one heart pumps the blood. It is a top-down management system. But that centralization creates a bottleneck. Every sensory input and every motor command has to travel all the way down from that single command center through long nerve pathways to reach your extremities. That biological commute takes both time and energy. The octopus completely abandons this top-down blueprint. It solves the complex problems of survival using an entirely different physiological architecture. This is an animal with zero bones. There is no rigid internal skeleton to offer structural support or to protect its vital organs. It is essentially a free-flowing mass of muscle and tissue. To understand how a creature like this actually survives in the ocean, we have to throw out our assumptions about how a physical body is supposed to be engineered. The starkest contrast starts with the internal plumbing. The cardiovascular system of an octopus operates on a completely different set of rules. Instead of a single pump, the octopus divides the labor across 3 distinct hearts. 2 smaller hearts are dedicated entirely to oxygenation, pushing depleted blood strictly to the gills. Once oxygenated, the 3rd primary heart takes over, pumping fresh supply outward to fuel the body. But this biological engine has a severe physical limitation. When an octopus swims rapidly, that primary central heart completely stops beating. Because sustained swimming effectively cuts off the body's main oxygen supply, the animal quickly becomes exhausted. To bypass this, the octopus avoids swimming long distances and spends most of its life crawling along the ocean floor. Crawling across jagged rocks and uneven terrain presents a massive physical challenge. The animal has to constantly coordinate 8 highly flexible, independent limbs. The solution to managing that complexity is a decentralized nervous system. The octopus relies on a network composed of 1 central brain and 8 smaller nerve centers, effectively giving it 9 independent brains. If one central brain calculated the micro-movements of thousands of suction cups, the system would crash. Instead, it delegates. Each tentacle's computing center processes sensory data and generates immediate local responses, never routing back for permission. If an arm encounters a crab or a rock, it independently figures out the exact angle, suction, and grip pressure required to latch onto it. By offloading these constant, minute decisions to the extremities, the octopus frees up its central brain. It turns what would be a massive processing bottleneck into an elegant system of parallel computing. This unique hardware layout translates directly into how the octopus interacts with its environment and survives against apex predators. With the arms managing their own movement, the central brain has the bandwidth to tackle complex cognitive tasks. Octopuses consistently solve mechanical puzzles, navigate complex underwater mazes, and easily unscrew jar lids to reach trapped prey. When threatened, the octopus uses its distributed nervous system to alter both the color and texture of its skin in a matter of seconds, blending perfectly into the surrounding rocks and coral. If that camouflage fails and a predator spots them, they deploy a secondary defense. The octopus ejects a dense cloud of black ink, creating an immediate smokescreen that disorients the attacker and buys time for an escape. And when it comes to the actual escape, that complete lack of an internal skeleton becomes its greatest mechanical asset. Without rigid bones getting in the way, the animal can compress its entire decentralized mass through incredibly tight crevices. As long as the small, solid beak at the center of its mouth can fit through a gap, the rest of the body can squeeze right through behind it. The octopus proves that high-level intelligence and extreme adaptability don't require the rigid, top-down structure we see in vertebrates. It survives and thrives by operating as a fully distributed network.